Welcome back. Uh, Here, what we want to show is that the partial derivatives are actually directional derivatives. Recall that the partial derivative of f with respect to x evaluated at the point xy is the limit as h goes to 0 of f of x plus h comma y minus f of xy over h. Now x plus h comma y can be written as xy plus h times the vector I, where I is the vector basis vector 1, 0. So notice that h times I is h comma 0. When you add that to xy, you get exactly x plus h comma y. So we can rewrite this limit in this way. Now letting capital X to denote xy, what we would be getting is that this limit is equal to the limit as h goes to 0 of f of x plus hi, f of capital X plus hi minus f of capital X divided by h, and that is exactly the directional derivative of f in the direction of I at the point x. So the partial derivative of f with respect to x is the directional derivative of f in the direction of I. Similarly, the partial derivative of f with respect to y is the directional derivative of f in the direction of the basis vector j. If we have a function of three variables, then the partial derivative of f with respect to z is the limit as h goes to 0 of f of x comma y comma z plus h minus f of x y z over h. If we let capital X to denote x y z, then x y z plus h can be written as x y z plus h times 0, 0, 1, which is equal to xyz plus h times the vector k. So we can write this ratio as f of capital X plus hk minus f of x divided by h. That is exactly the directional derivative of f in the direction of the basis vector k. So what we find is that partial derivatives are basically directional derivatives in the direction of the basis vectors.